Live from Ludke's COVID quarantine couch in Rothschild, Wisconsin. This is Mr. Ludke, and I'm going to give you directions on how to do my name and DNA. So if you're viewing this in the spring of 2021, the reason I'm not at school is because I tested positive for COVID. So these will be your directions on how to do my name and DNA. If you're viewing it at a year later, hopefully it's just because you're absent or something, but these will be the directions on how to do my name and DNA. All right. So what you're going to want is you're going to want to write your letters of your name where it says name. So, all right. So I am Mr. Ludke. And let's say that your name has to be at least 4 letters long. Okay, and honestly, I wouldn't go much bigger than 6 letters long, because if you go bigger than 6 letters, your DNA segment is going to get very long. All right, so one thing that you need to recognize is that this whole thing right here is representing a protein molecule. Okay, and what we need to do is we need to figure out the DNA code that would store the information for your name. So that's what this table is for right here, where it says DNA codon. So make sure you're looking at this table. Do not look at any other tables, because otherwise you're going to get confused. All right. So what I got a code for is I got a code for an M. So if we look in here, there are 3 possibilities of M's. It doesn't matter which one I pick, I just need the code for an M. So for me, what I'm going to do here is, let's just say I pick this one right here. I want a code for that particular M. So then my first base that I would need would be a thymine. So I'm going to write that in right there. Okay, my second base that I would need is going to be a cytosine. And then my third base that I would need would be an adenine. All right. Then next I want a code for an R. So again, there are 3 R's in here. It does not matter which one I pick. I'm just going to pick one of them. So I'm going to pick the top one again. So to figure out the code for an R, so the first base that I would need is I would need a guanine. Then I would need another guanine. Then I would need an adenine. So that sequence of GGA would code for R. So I'll just do one more as an example here. So in the case of an L, it looks like there's only one possibility for an L. So then that case must be, the code would have to be a guanine, a cytosine, and then a thymine. All right, so why don't you go ahead and push pause and go ahead and figure out yours. Okay. So now that you've got your code figured out, what you need to realize is that what you determined here, this is the coding DNA strand. Okay, that's what that sequence is right there. So now when you go to actually build your DNA molecule, so you're going to have these sugar phosphate backbones in the room, and they should be green. Most of the time we photocopy them as green. So if we remember, we had the sequence of, so I'll highlight it here, we had the sequence of TCA. So now when I go to build it, on my sugar phosphate backbone, if I look at this right here, so there's my first base, a thymine, then going down, it would be a cytosine, then going down below that would be an adenine. Okay, then if we go back up and we look at the next codon here, so we had that sequence of GGA. So then here it is, GGA. So then what you would need to do is then you would need to glue together multiple sugar phosphate backbones in order to get enough nucleotides in order to store the information for your name. Now again, remember that that is only the coding side. And of course, DNA is a double helix. So now there's a couple of different ways that you can figure out the non-coding side. So we could do it this way. And it's just the idea of complementary base pairing. So here I have a thymine. Well, pairing with that would be an adenine. Next I have a cytosine, so pairing with that would be a guanine. Then thymine, cytosine, cytosine, thymine, cytosine, guanine, adenine. It's just the idea of complementary base pairing. Now, when you do this, what I would not do is I would not build the coding side separate and the non-coding side separate and then try to put them together, because usually when you try to do that, the bases don't line up well. So what you would have is, and I wish this one right here was flipped around. Like I wish that this sugar was on the other side so it was facing the T. But that's when you actually put it together, that's the way it's going to be. So then what you would have is then pairing with that thymine would be the adenine. Okay, then pairing with this cytosine would be a guanine. And I would like glue them together one by one as you go through this. And then thymine, and you just keep going right on down. So I think that is pretty much all I really need to tell you. If you have any questions, first try to figure it out with the sub. If you can't figure it out with the sub, email me and we can try and figure out. But all right, do the best you can with it. Have fun. All right, thank you. Bye.